All right. Hello, everyone, and welcome to The Current. This is the North Central Region Water Network's Speed Networking webinar series. In this series, we talk about water and water-related topics, and we introduce you to folks that are doing great things across the region and across the country that relate to how we manage water. So my name is Rebecca Power. I am joining you from the University of Wisconsin-Madison Division of Extension, and I will be your moderator. Since some of you may be new to the North Central Region Water Network, we are an extension-led collaboration among 12 land-grant universities in the upper Midwest. Today's topic is a hot one. It is carbon markets and carbon credit agreements. And as you all know, there's been a lot of talk about carbon credits and carbon credit agreements. And, as I was thinking about this session, I was thinking about the Luna Leopold quote and how the quality of our water is a measure of how we live on the land. And I think it's similar related to how we manage water is directly tied to how we manage soil carbon. And agriculture, as you know, is a critical part of this equation. So in this edition of The Current, we will be grounding ourselves, so to speak, in some recent research on soil carbon and soil carbon sequestration brought to us by Greg Stanford, who is a research scientist and senior lecturer at the University of Wisconsin-Madison. And then Dave Aiken, who is a professor of agricultural economics at the University of Nebraska-Lincoln, will give us his take on what producers need to know or consider before entering into some sort of carbon credit agreement. And then finally, we'll hear from Emily Oldfield, who is a scientist with the Environmental Defense Fund. And she will be telling us about her research and some of her collaborators' research on how different companies and organizations are going about verifying soil carbon sequestration and the different protocols that those groups are using and why it matters. A few notes to help you participate in our session today. So we will be having a dedicated Q&A session at the end after each of our presenters is done. So you can submit your questions for our presenters through the Q&A panel. If you're experiencing technical issues or have questions about the North Central Region Water Network or the current webinar series as a whole, please use the chat feature for those technical questions or questions that are unrelated to our topic today. The chat feature is available at the chat icon at the bottom of your webinar screen. If you're having audio issues, there is a phone-in option, and that option can be accessed by clicking the up arrow on your mute icon and clicking switch to phone audio. We are recording the session, and the session will be available at northcentralwater.org. All right, next slide here. So as I said, here's just a brief introduction to our presenters today and the topics that they will be covering. So Greg Stanford is going to be talking about farming for carbon, Dave Aiken, carbon agreements and what producers need to know or ask, and then Emily Oldfield, agricultural soil carbon credits and making sense of protocols for carbon sequestration and net greenhouse gas removals. All right, so with that, just a little bit more about Greg, our first presenter. I won't read that all. You can read that. And yesterday, I'll tell a secret about Greg. He was wearing that same shirt during our practice session yesterday, but I think he changed that for today. So anyway, welcome, Greg. I will stop sharing my screen so you can share yours.
Great, thank you. Right, so hopefully that's worked. Great to be here and to see the group we've got. My intention is really just to discuss the concept of farming for carbon and maybe calibrate expectations for what we may or may not be able to do with the soils and agricultural practices. There's really a sea of scientific research looking at carbon sequestration that dates back decades, ranging from things like fertilization, more plant biomass equals more carbon, through things like no-till, cover crops. This is a really hot topic right now. Biochar, the idea that we might be able to return plant biomass in perhaps a more stable form to the soil. Biodiversity, this idea that as we make rotations more complex or have multi-species assemblages, there's some complementarity in root morphology and depth that could add to the carbon building potential of a system. Inclusion of perennials. This is really like a combination of no-till and cover crops in that we're reducing the tillage, but also increasing the amount of living cover. And then, if you've got perennials into a system where you start talking about perennials, then obviously you're starting to discuss forages, and there's openings for potentially reintegrating crop livestock systems. This is just a selection of some recent studies on these topics. There's hundreds, if not thousands of articles on each one of them that can be perused. And so, it's really easy to get lost in that sea of research data. And so I really look for three key methods or pieces in these types of experiments in terms of something you can really take to the bank from the standpoint of reliable sequestration numbers. And those key pieces are that any comparison, whether it's between different methods or over time in soil carbon, is making sure that corrections are made to compare equivalent soil mass between two groups or two time periods. It's also critical, I think, for us to be looking at studies that are evaluating the entire soil profile. We know that the exciting stuff is happening typically in the top 30 centimeters, but over 50% of the carbon is typically below that. And then, the importance of studying things over time, which is difficult because we can't go into the past. So, when we're talking about additionality or paying somebody for a change in practice, then, looking at different treatments right now is valuable. If we're really concerned with whether or not we're sequestering carbon, it's essential that we are pulling from data that looks at carbon accrual or loss rates over time. So I just want to look at two studies to kind of illustrate perhaps what we could expect in the north central US. The first one is work that I've done here at the Wisconsin Integrated Cropping Systems Trial in south central Wisconsin. And this is really just looking at change in metric tons of carbon per hectare over a decade in the case of prairie and CRP here, or some kind of more typical cropping systems, pasture forage systems with corn and alfalfa and grains over a 20-year period. Anything less of it or left of this center line is a loss. And anything where those error bars or confidence limits overlap the line is kind of no significant difference. And so, what we've seen in the first 20 years of this long-term experiment is that our grassland systems, whether it's managed pasture or our prairie plantings, seem to be able to hold on to the carbon that we have. But in our forage systems and our grain systems, whether they're organic or no-till, whether they include manure or cover crops, we just simply haven't been able to hold on to the carbon that we started off with. And so, what that translates to is a loss of up to a ton and a half, a metric ton and a half of carbon per hectare per year, or somewhere hovering around zero. Some other research that's soon to be published from colleagues at the Kellogg Biological Station looked at very similar systems with a very similar age trial. Here they've got no-till, reduced input, and biologically based agronomic systems with things like corn, soybean, and wheat. And then they have forage systems with alfalfa in them. And this study was over 25 years, also evaluating deep carbon. So, in Wisconsin, we got down to 90 centimeters. Here we're getting down to 100 centimeters. And in the case of this study, you can see that all of the bars are to the right of that zero line, indicating sequestration. The greatest sequestration at Michigan was in the perennial forage system, followed by those kind of biologically based systems with cover crops, and then no-till. But in this case, all of them are sequestering carbon, and that translates to about just shy of a quarter to maybe 0.7 metric tons per carbon per hectare per year. So, similar systems, similar timescales, similar methodologies. We're seeing pretty different results here. And I would just say that if you really dive into the research that is using these three kind of key methods to get at carbon accrual rates, you'll see that by and large, most studies come out showing that you're either plus or minus about half a metric ton of carbon per hectare per year. So some studies are showing sequestration kind of in that range of half a metric ton of carbon per hectare per year. Others are seeing losses in that half a metric ton. And to put that in imperial units, it's about just shy of a quarter ton per acre per year, or 0.22 tons per acre per year. So what's going on? Well, place is important, particularly when we start talking about carbon sequestration. And I think this is going to be critical when we start talking about carbon markets. Our colleagues in Michigan did their work on forest-derived alpha sol that's coarse texture, so it's much sandier and has lower background carbon levels. And our study, if you believe where my little red pin is pointed, was in the middle of the Empire Prairie, which is the largest swath of tallgrass prairie historically in Wisconsin. And so we're working on a fine textured silt loam soil with high background carbon levels. And so, where you are farming, where a practitioner is intending to build carbon is going to have a big impact on their ability or the speed with which they can change those metrics. And this has huge implications, because if we take a look at the United States and the soils that dominate the United States, you can see this big green strip. These are the UDOLs, the prairie soils or the mollisols in humid conditions. And just west of them are the USTOLs, the drier mollisols. Now, all of these soils have relatively high background carbon level. And if we look at where we do most of our farming for corn and soybeans, it's nestled right here on what once was the tallgrass prairie. So in my mind, this says we're starting off in most cases with our agronomic systems in the north central US with relatively high background carbon levels. It's going to take us throwing everything and the kitchen sink at these soils to try to move them in a meaningful way. And we should be considering that when we start talking about carbon credits. So just to conclude and give the other presenters time, hopefully I haven't gone over 10 minutes. I just want to throw out that a lot of our soils in the north central US are mollisols, not all of them, but a lot of them. And building carbon on mollisols is going to be tricky. This is why we often target, when we're talking about bioenergy crops or things like that, more marginal landscapes where we can change soil properties more quickly. On mollisols, perennial systems or perennial phases and rotations are going to be key. There's other things that can do it. I know there's some studies showing that as tile drainage starts to kind of stop working and subsoils become anaerobic, we can begin to accumulate carbon in those subsoils. But we really need to do more than just throwing a cover crop in here and there and think about stabilizing that landscape. I think it's really important that we have realistic expectations that we're going to hover around zero. In some places, we're going to be gaining about half a ton a hectare per year, but in other places, we might be losing about the same amount. And validation, because this is all today's discussion is about carbon markets. Validation is going to require accurate methods if we want to do something more than just feel good about what we're doing. It's one thing to implement these practices and get excited about what they're doing for the soil and potentially the climate, but we need to be really critical in our evaluation. Otherwise, we could be, just exacerbating the problem that we're all dealing with. And so, I just really like to say that as we're talking about soil carbon's exciting. It has so many amazing properties, but it's really got all these co-benefits, or it could be considered a co-benefit, as Emily mentioned yesterday, with things like soil health, water holding capacity, water filtration and quality. So I think it's important that we remain open to what this kind of regenerative agricultural management can do in other areas and not be so maybe myopically focused just on carbon. And that's all I have. Hopefully I've made it in time. Thank you all very much.
Thank you, Greg, so much for introducing us to just that great overview of what's actually happening in the soil, particularly in our part of the world. And as you showed, there's quite a bit of variability, but we have to, so we need to know about that variability as well as directionally where we seem to be headed. So I know our next two speakers have been thinking about that as it applies to carbon, the potential for carbon markets and carbon agreements, as well as the verification issues. So with that, I am going to share my screen again and introduce our next presenter. So next we'll hear from Dave Aiken, who is a water and agriculture law specialist with the University of Nebraska Lincoln Department of Agricultural Economics. And thank you so much for being here, Dave. And this was a fast screen share on my part, and I will stop now so we can hear from you. Looks good.
There we go. Thank you very much. I thought we ought to have a little perspective in terms of how does carbon sequestration look in terms of the bigger picture of carbon emissions in the United States. For the last year that we have data, carbon sequestration for the United States land mass is 12% of total carbon emissions. And of that 12%, 98% came from forests, and the remaining 2% come from cropland, grasslands, and wetlands. And really, it's probably about 1% grassland and 1% wetland. Croplands are negative. So when you're talking about doing anything meaningful about climate change in the US, ag carbon credits are not going to save the day. Okay, so what is the ag carbon credit? What are the credits and what are the markets? The credits are where you may get payments. If you're a producer, you may get payments now or down the road for implementing new practices that increase carbon sequestration in the soils or otherwise reduce greenhouse gas emissions from, say, reduced field operations or reduced fertilizer applications or something like that. The markets seem to be more of a PR thing where Microsoft or Facebook or Amazon pays an aggregator, gives them a pot of money and says, we want this many tons of carbon sequestration or carbon offsets so that we can say we're carbon neutral or that we've reduced our carbon footprint. This is private. The government doesn't have anything to do with this. These are private contracts between, the contracting parties. And there are no standards and there's no regulatory oversight. So this is the wild, wild west. Critics call this greenwashing, and I think that's a pretty fair comment. There are two types of carbon markets. This greenwashing one are the voluntary markets where there's no rules, no oversight, no government. And the compliance carbon markets are the opposite. There's strict government oversight, and the people who are buying the carbon credits are legally required to reduce their emissions. And this is one way to do so, but you have to jump through an awful lot of hoops before you get the approval to offset those emissions. And what's driving the carbon market right now? Well, the big thing is the election of President Biden, because he's campaigned on doing something about climate change. And so there are speculators who have jumped in and said, okay, if he's going to regulate carbon emissions within the US, then we're going to tie up a bunch of ag carbon credits and sit on them and hope that that their value goes up in the next few years and we can sell them and make a bunch of money. The other big group that's involved are the firms who want to become ag carbon market professionals. A lot of these are ag groups already, or ag companies, and they are developing pilot projects. They're sticking their toe in the water, so to speak, trying to figure out if they can do this and get their platform ready so that if the market takes off, they can ramp up their capability as well. And then I already talked about the PR stuff. One important thing that's happening in Congress to try to provide a little bit of regulatory, or at least the government oversight indirectly, is through this bill that was passed in the Senate but is cooling its heels in the House of Representatives. It's Senate Bill 1251, and it will put USDA in charge of developing voluntary standards for the ag carbon markets. The important ones would include measurement and verification protocols. It would also allow for voluntary certification of ag climate market professionals. That includes the professionals who are on the buying and selling side, or the professionals who are doing the technical work on the measurement and verification side. This would not put USDA in charge of the carbon markets, but hopes that whatever they come up with would influence the carbon markets to make them a little more transparent, maybe a little more producer friendly. Okay, will the USDA have a carbon bank? And we already got a question in saying we've been storing extra carbon on our land for a long time. Nobody cares about that. They just care about new storage or incremental storage. And that's where the carbon bank ideas come from. This is proposed. It's not operational. USDA is doing a pilot, but the way it would work, it seems that it would work, would be that, it would either be, it could be like CRP, where you bid land in, and the lowest bids get the contracts, or you could get paid so much an acre for specified practices, climate smart practices, for example. And it could go to folks who have been doing this for a long time and who are not increasing, but they increased maybe some time ago. It would be completely separate from the carbon markets, and it's possible that people could, get payments from USDA and still sell carbon credits in the private carbon markets. So, but Secretary Vilsack says it's, the carbon bank would be designed for farmers, not for the carbon markets. Okay, what should producers watch for? And you need to know your costs, because if you're going to sell a contract in the private carbon markets, you're going to have to change what you're doing. You either have to do something new or stop doing something that you've been doing that's presumably has made you money. So you have to know what your costs are to know if you're going to come out ahead on the deal or not. There's no, you could lose money on it. You need your attorney to go over it with a fine-tooth comb, and they will go through all the fine print and find all the gotchas that are in the fine print and make sure that you know what they are, so that you better understand what it is you're getting into and whether you really want to take the leap or not. And I would be cautious about the carbon contracts, because it could go either way. But if you do it, be sure and have your lawyer go through it with you line by line and make sure that you understand everything that's in it, because you might find out that you have a lien on your farm for the next 20 years to make sure that you maintain your carbon saving practices that you got paid for a while, but now the payments have stopped. You'd want to know that up front before you signed anything, I would think. Okay, the current carbon markets are, largely environmental PR, in my opinion, and there's no rules. So let the seller beware. These markets aren't going to fire up, and the prices aren't going to improve unless we begin with serious climate policy and regulation in the US, which we don't have. We only have on a regional basis. If the Biden energy, climate programs don't get underway, there will not be much in the way of an ag credit market, an ag carbon credit market. Okay, the top first reference for more information is back to the University of Nebraska. We've got a page that has several podcasts and webinars like this. And if you're, so that you can pursue some of these topics in more depth. The next two are great publications from Iowa State and Purdue. The Iowa State one lists all and summarizes all the companies that they could find dealing in the ag carbon credit market. The Purdue one is just a good introduction to the whole issue. And then there's a 4-hour carbon market webinar, which is basically this webinar, only it's 4 hours long. And they have an ag economist. Well, it's a great webinar that it has agronomy, it has law, and it has farm management. And so if you're interested in really learning about this, that's the place that I would go. Thank you.
Excellent. Thank you so much, Dave, for your take. And that's why we call this a speed networking webinar series, right? Because there is a 4-hour version, but here you can get the tease. All right. Thank you so much. And now we are going to go to our final presenter. Okay. Are you seeing the right thing? Just making sure.
No, we see your email.
You see my email.
Yeah.
You don't need to see my email. All right. How about that?
There we go.
Great, thank you. All right, so without further ado, Emily Oldfield is our final presenter today, and she is a scientist with the Environmental Defense Fund. And she has a specific focus on this topic, agricultural soil carbon. So a little bit more about her and her street cred there, or her field cred. And she has a report that's out not too long ago, and she's going to be telling us a little bit more about the results of that report and other stuff that she's gleaned in her experience. So I'm going to stop sharing now so we can get right on to Emily.
Great. Okay. Can everyone see?
Yes, perfect.
Thanks so much for having me. Looking forward to the discussion. And as Rebecca mentioned, I work at Environmental Defense Fund, and we published this report earlier this summer in collaboration with Woodwell Climate Research Center that really delved into a lot of these measurement, reporting, and verification protocols. So we tried to get into some of these sticky issues that Dave covered in his presentation in terms of this voluntary carbon market, which is expanding at a really rapid pace and just growing at, it seems like a new announcement is made about every other week in terms of, new activity in this market. So I'll provide a little bit of context and then get into some of the specifics that we found in terms of delving into some of these protocols. So the context for this work was this rapidly expanding US voluntary carbon market. And so a lot of activities happened in the past couple of years, from recently published protocols from a number of the carbon registries to emerging marketplaces that are establishing their own protocols to generate verified soil carbon credits, to a number of ag companies that are announcing payments for carbon sequestration as well. And it's unclear for some of these instances whether these companies will be using one of the protocols published by the registries, whether they'll be working with one of the marketplaces, or whether they might be developing yet another protocol. So all of this heterogeneity and activity has led to some serious concerns about the market integrity. So there's been a lot of coverage recently, and here are just 3 recent headlines about these different approaches, and how, as Dave mentioned, it is a bit of a wild west out there, and there are serious concerns arising about the different approaches to measuring soil carbon sequestration and greenhouse gas reductions, and then accounting for additionality. That's a big one that receives a lot of attention. And as mentioned, additionality is basically the assurance that, you know, any carbon sequestered, any carbon dioxide that's drawn down from the atmosphere and sequestered in the soil is new and additional to what would have happened under a business as usual approach. So within this context, we reviewed 12 publicly available protocols from a number of the registries and some of the marketplaces, protocols that are domestic in scope and also international. The goal of this report was really to identify how each protocol measured and or estimated soil carbon sequestration, net greenhouse gas reductions, and also to understand how each protocol addressed these structural and accounting considerations like additionality, reversals. So, you know, how the protocols are accounting for potential reversals in carbon storage due to management or climate things that happen, leakage and permanent. So making sure that that carbon stays in the ground. So we didn't want to, you know, we weren't trying to assess the accuracy of these protocols or to quote unquote pick a winner. We really wanted to understand the lay of the land and just understand, you know, how these protocols, you know, what the documentation states in terms of getting from, you know, implementing new practices to these verified carbon credits. And so this table here outlines some of the key things, you know, some of the key results that we uncovered. And there's a lot more context in the report, but this table kind of sums up some of the key differences represented among all these different protocols. And so I'll just highlight two of the big ones, measurement and additionality. So on the measurement side, we see a number of different approaches being taken to estimate soil carbon sequestration, from direct sampling approaches that require physical soil samples. As a soil scientist, I always appreciate direct physical soil samples, but from a farmer perspective, it can be, you know, the drawback there is that soil carbon takes a while to accrue and to actually measure appreciable changes. So credits are generally issued over longer timeframes under those kinds of approaches. There are approaches that use only models, so using complex soil biogeochemical models that have been developed over, you know, over many years to basically be able to estimate soil carbon sequestration and net greenhouse gas reductions using a variety of inputs related to soil type, management, you know, climate characteristics. And then there are approaches that combine both sampling and modeling, and newer approaches using remote sensing calibrated with ground truth sampling. So there's a whole sort of suite of ways of measuring and estimating soil carbon sequestration. And the goal of these protocols is really to try to achieve that sweet spot between accuracy and scale. And that's challenging because measuring soil carbon is really time intensive and expensive, and doing so at scale is hard. I'll also just highlight additionality here. That was one of the issues that really had the most variability represented among the different protocols, from criteria that required, you know, that new practices are not already implemented on a percentage of land area, to what I'd call more lenient approaches that say, you know, after the onset of soil sampling, any carbon sequestered after that point is additional. So that means, you know, a farmer could have adopted no-till or cover cropping 25 years ago, and as long as, you know, they've enrolled in a program or this program and continue to accrue carbon after the onset of sampling, that counts. So, you know, given all the variety and variability and different ways of accounting for these different issues, you know, we came to the conclusion that, you know, in practice, depending on, you know, the protocol used, if it's applied to the same, if different protocols are applied to the same project area, they will likely result in different numbers of credits, which means different estimates of carbon dioxide removal. And from an environment perspective and a climate perspective, that's, you know, that's problematic because we want to make sure that these credits actually deliver the climate mitigation benefits that we want them to. So just to provide a quick example here on additionality, looking at the criteria that new practices are not already implemented on a percentage of land area. So for example, if no tillage is practiced on 45% of land area containing a given project, that project would be eligible for credits under CAR's soil enrichment protocol, but not under VERA's VM42 or Gold Standard's SOC framework. Similarly, with these look back periods, practices adopted in 2012 would be eligible for credits under NORI, Regen Network, and B Carbon, but not any of the other protocols. So just to summarize, our report highlights these three key points in a lot greater detail, but here are the take home. So soil carbon protocols take really different approaches to measurement, reporting, and verifying net climate impacts. And this variation makes it really difficult to ensure that climate benefits have been achieved. And so we think that until these variations can be resolved, paying farmers to sequester soil carbon remains an uncertain approach to greenhouse gas mitigation. But as Greg pointed out, we still believe, and this is no small point, that these practices really can deliver really important benefits for climate resilient soil health and water quality. And as mentioned in both previous talks, carbon sequestration might be considered a really important co-benefit of these practices that we know have really important soil health outcomes. I think soil carbon sequestration can become an important mitigation strategy if there is agreed upon, credible, cost-effective, and consistent measurement, reporting, and verification. So we want, this range of disparate approaches to kind of consolidate around, a system that we think can really be, result in robust, real, transparent, and consistent credits. So that's it for me, and thanks for having me, and I look forward to everyone's questions.
Excellent. Thank you so much, Emily. Okay, so I will now we'll dive into some of the questions now, and I'm going to not put up the Q&A answer session slide just so we can see everybody here. But we'll start going through some of the open questions. So, let's see. So Zach, I'll first go to Zach Caston's question. Zach asks, and this was during Greg's presentation, if that minus 1.5 ton number remains consistent across different regions, or would you say that's specific for the Prairie Upper Midwest? And I will also just tie in Nancy Turk's question, which is about sandy soils, because I think you referenced that briefly in your talk, and what happens in sandier soils as opposed to deeper, finer soils.
Sure. Yeah, thanks, Nancy and Zach. With respect to the negative 1.5 metric tons per hectare, that's actually a system-specific loss. That's continuous corn, tilled continuous corn here on the Empire Prairie. So, we might expect similar losses in systems like that across at least the historic tallgrass prairie, the Udalls, but that seems like a pretty substantial loss to me. I might expect other systems that are losing carbon to be losing at a lower rate. That was just an example from Wisconsin. With respect to sandy soils, Nancy, you're totally right. We have well aerated soils. There's not a lot of sites for carbon to be adsorbed or fine silt and clay minerals to aggregate and start to protect carbon. And so what we see is, because they're low in carbon, if you can grow a crop successfully, which if it's very sandy often takes irrigation, you can accumulate carbon and you can accumulate it quickly. So in the central sands of the United States, central sands of Wisconsin, where we irrigate, we've essentially in the last 30 or 40 years built entire A horizons, just because these areas that don't support, historically don't support that kind of plant biomass can support it. But the point you make is spot on, that if we were to take irrigation out of the question there, the inherent nature of the soil would result in a very rapid loss of that carbon. So, we can move the needle if we're starting with a low background level of carbon, which doesn't necessarily mean that they're sandy soils. But whether or not that carbon persists once we add it is going to be very tied to the soil mineralogy and the climate. Further north and cooler, wetter climates, we're going to see carbon stick around longer if we can get it into the system.
Great, thanks, Greg. Another follow-up question by Amanda. Are the sequestration rates reported by you, Greg, and others that you're sharing the research with us only soil carbon, or is above ground biomass included as well?
This is soil carbon. So I think about soil carbon as the great integrator of cropping systems or ecosystems, in the sense that as soil carbon changes, it's integrating fine root turnover, mycorrhizal fungi, crop removal. So there's certainly carbon being taken off these systems and exported, but to draw a box around your system, in this case, we're talking about the carbon that's there. So for the prairies, which this ties into another question, we do burn those. It would include whatever char re-enters that system after burning, or whatever litter fall occurs every fall. So it does integrate some of that above ground biomass, but primarily it is the carbon that makes its way into microbial biomass and eventually sticks around in the system.
Thank you. Tom Kriegel has a question. Are forests so much more effective in sequestering carbon on a per acre basis? And if so, is that because the carbon is sequestered in the tree that may stay in the tree for decades, or are forests also more effective in sequestering carbon in the soil in addition to the carbon that isn't in the trees? And I don't know, maybe we'll start with Greg.
Yeah, that's a tricky one. That's a good question, Tom. I think this also ties into something later on in the questions. Carbon markets for forests are so well developed because we can see them. We have really great allometric equations to measure the amount of biomass above ground. And so it's easy to track. We can see how many tons of carbon we're adding per acre or hectare every year. So I would say that's the reason why forests are more reliable in terms of carbon storage. Now, if the forest burns, that's a different topic. With respect to the soil component, some of the most carbon-rich soils in the world are the spodosols, which are forest soils, but they're geographically limited, and it's really the climate that drives it. Typically, we think about alpha sols as kind of our major deciduous forest soil in the United States and throughout the world. And those tend to have lower soil carbon content than our grassland soils, particularly our humid climate grassland soils like our tall grass prairie. So, I'm sure people have heard about the prairie being called the inverted forest. The idea is that C4 plants allocate more of their photosynthetic biomass below ground than they do above ground. And so we do tend to see higher carbon stocks in this kind of farming region of the world under grasslands than under forests.
Thank you. Let's see. We'll go to Marie's question for anyone, so you can all get in the game here. How would you advise farmers that are being offered annual payments for carbon credits? They're calling. I'm sure many of you who are participating today get calls asking for advice on what to do. And she's saying Bayer is aggressively trying to buy credits. So just what's your unvarnished advice and I'm sure it's variable depending on the situation. And Dave, maybe you want to respond to this initially, because I think you had some thoughts in your presentation.
Yeah, I would first of all, make sure you understand your costs. And sadly, most producers don't, but you may have to work with an extension farm management specialist or something like that to make sure your costs are realistic, and then understand the costs of what the change is that you have to make to, if anything, but most of them would require some kind of change, what that does to your cost structure and whether it's positive or negative. And then if they're offering you a written contract, take that to your lawyer. You know, don't try to be your own lawyer, because that would be the biggest mistake that you could make. So have your lawyer look at it, go through it with you to make sure that there's nothing in there that is going to, you know, bite you in the end.
Great. Thank you, Dave. Anyone else want to comment on that? Okay, hearing none, we'll go to a question for Emily. Why is there such a diversity of protocol? This is from Scott Satterwhite. He's saying marketing of the buyer, advanced technology, just because folks are trying to figure it out. What's the answer?
I mean, that's a great question. I think a lot of it relates to, new and emerging technologies related to measurement, like the remote sensing approach. I also think, in terms of the additionality, variability represented among there, I think everyone realizes that in order to have actual climate impact, we need these markets to scale. And so having different thresholds of additionality, I think the different protocols sort of represent different approaches to that, saying we can't be so strict on this requirement if we really want to enroll a ton of farmers and sort of have agriculture be part of the solution. So I think sort of different theories of how we can actually achieve, really, widespread practice changes at scale is a big element of why there are so many different approaches represented.
Thanks, Emily. Vincent has an interesting question here. They're all interesting, but was the prairie managed with, was that prairie managed with fire? You would think it would be better than pasture due to deeper roots, et cetera. Does the fire set back sequestration rates by burning off the above ground biomass? So what's the relationship between fire, and I don't know if any of your research addresses that, and carbon sequestration?
Well, the answer is that yes, the prairie is managed with fire, typically every 2 or 3 years, to mimic maybe what a prairie would experience historically. I mean, nobody really knows how frequently an area burned, but with respect to sequestration rates, I don't really have that data. When we burn the prairie, we do generate some char, and there's a lot of research looking into pyrogenic carbon and its persistence in soils. So there's a possibility that leads to long-term carbon accumulation in soils. But burning also tends to kind of rejuvenate prairie stands, and they grow better after a burn. So, it's possible that it could actually enhance simply by kind of the regenerative nature of the burn, but I'm just speculating. I don't know.
Mm-hmm. Okay, thanks, Greg. I know there have been some papers in the past 5 years, I think, trying to get more closely at that question. So maybe we'll have to revisit this topic with a little bit different angle on it. Thanks, Vincent. Anna Cates has a question. Given the difficulty of verifying carbon sequestration and all of the middle groups involved in the process, how much would C credits need to be worth to pay the farmer a meaningful amount? So I'm not sure which of you wants to start there.
I'll take a stab at that. There's a great study done by Ray Massey at the University of Missouri for the Missouri Soybean Board, and it's climate change in Missouri agriculture, I think is the title of it. But if you do Ray Massey, M-A-S-S-E-Y, and climate and agriculture on Google, you'll find it. And he's got a chart somewhere in the first 40% of the report that talks about break-even prices on different carbon saving practices for farmers. And I think there may be an Iowa State report that looks at some of those same issues. So those are the two places I'd look.
Okay. Emily, anything to add there?
Yeah, I'll add, I mean, so like I mentioned, a lot of these protocols are trying to achieve that sweet spot between, you know, their best guess at accurate estimations of CO2 removals and cost effectiveness. And so a lot of these programs, especially the CAR Soil Enrichment Protocol and Vera's VM42, rely on operating at huge scale. So aggregating projects over really wide range. So, you know, basically they can achieve a sort of central tendency. So the thought is, you know, taking direct soil samples at the farm scale to get at a level of uncertainty required for credit estimation is just totally not efficient, and would be super expensive. But when you sort of scale up, you know, you can basically achieve efficiencies because you're getting at, you know, sort of a mean average. You're capturing that central tendency, and the variation that exists at the farm scale kind of gets sort of washed away from that equation. So that's why like Indigo Carbon's recent project has something like 275 participating farm fields and stuff like that. So because you just need to amass such a huge scale to be able to actually get, you know, cost-effective MRV.
Mm-hmm. Great, thanks. I'm going to stay with you for a minute, Emily, and looks like maybe there was some typing going on related to Ed Weinberg's question, but want to answer this one live. When best management carbon sequestration practices reduce fertilizer requirements, when that's the case, can there be, quote, additional carbon credits for reduced emissions, CO2 emissions obtained through fertilizer avoidance? Is that something that's being discussed?
Yeah, so a lot of the protocols, they account on a sort of net CO2 equivalent basis. So they'll use some of the sort of, they're called basically emissions factors. So if there's reduced fertilizer inputs, there's sort of these broad scale calculations that go into ultimate credit generation in terms of crediting for those, you know, for those emission reductions as well. But, you know, reducing fertilizer is kind of one of the best ways, because it's permanent, right? And it doesn't, there's no risk of, you know, sequestered CO2 being released at a future date. So it's, you know, it definitely should be something that we prioritize in terms of, you know, permanent non-reversible CO2 reductions.
Mm-hmm. Okay, thanks. We've started getting at this a little bit, but maybe getting into more detail. Laura Hicklin and Jessica, I'm gonna butcher your last name, but Hohensiel, ask about true cost of credits, which we started talking about a little bit, but specifically relating to the fact that these practices, you know, there's a significant public investment in these practices through USDA, states, and local cost share assistance. So anything to say about that, that part of the equation for how these practices get paid for and how that relates to carbon markets?
Well, I'll take a stab. I think that USDA is probably going to fold a lot of programs into climate smart agriculture, and it'll look at modifying its, you know, how certain conservation practices are cost shared and that sort of thing. But remember that whatever USDA does is separate from the carbon markets. You know, it's not, unless you think that the carbon markets are going to cause farmers to undo conservation practices that have been implemented in the past. You know, I'm not seeing a threat from carbon markets to existing conservation programs. and those public investments that have been made.
Yeah, I think everyone might agree that the price of carbon has to be valued much higher than it currently is. To make it worth it for farmers to take the risk and, buy the necessary equipment and change up their practices, to actually value it at what these companies who want to reduce their emissions should actually pay for it.
Mhm. Great. Thank you. There's a question about the UN 4x1,000 program. Another type of program? I don't know, Greg, maybe you want to start with that one.
Yeah, the idea behind the 4 per mil program was that if all of the Earth's soils could sequester, 0.4% more carbon every year, we would be able to at least offset the amount of CO2 emissions annually. And that's been looked at a lot. There was a study in 2018 by Missini et al. That tried to really break that apart. And they figured that in order to do that, we would have to sequester about 0.6 metric tons per carbon per hectare per year. And even in their kind of very sanguine assessment, they thought we were maybe capable of accruing 0.2 to 0.4 metric tons of carbon per hectare per year globally. And the reason is because some soils just, aren't going to sequester much more carbon. There's bogs and muck soils that are, close to, if not at, saturation from a carbon standpoint. And with climate change, the fear is actually that with changing hydrology and warming, some of these, pretty big stores of terrestrial carbon will actually start being released as things become more aerobic and warmer. So I think that the takeaway that I've gotten from the Missini et al. Paper is that best case scenario, we probably can't meet that 0.6 megagram per hectare per year rate globally. I mean, yeah, the gorilla in the room is that we need to burn less fossil fuels. I mean, we can't rely on, soils have a lot of impact on the global carbon cycle because there's 2 times more carbon in the soil than like in all the vegetation, or 3 times more. But ultimately we can't rely on soils to solve our fossil fuel problem.
It's a nice, we're not going to end quite yet, but that's almost a good point to end on. I'm going to try to take a couple more questions here. Tim asks if we could pay woodland owners to cut fast growing trees such as aspen and not harvest to leave the carbon, so some more on, forest related managements. And particularly is asking about smaller timber sales.
There was the comment earlier, and maybe Emily, you can jump into this, but there was the comment earlier that, older forests are leaky, and it's these young forests that are really pulling carbon out of the atmosphere. I've heard a lot of discussion about returning to more timber use in buildings.